Here's what the quantitative increases in ice melting looked like. When we pre-wetted with straight mag chloride brine, it increased the ice melting rate of salt compared to dry salt by a factor of about 7 over the first 3 hours. With plain salt brine, it increased the rate by about 3, factor of 3. And the hot mixes, we looked at 2 hot mixes, one with 20% mag chloride blended with salt and one with 40% mag chloride blended with salt brine. And these had intermediate values in between plain salt brine and mag chloride brine. So in this graph here, that's what these 2 lines are. So what you see is that as we go from plain salt brine to a 20% hot mix, 40% hot mix, to 100% mag chloride brine, we get a steady increase in the ice melting rate of salt. Now, you may again have posed the question in your minds about the realism of the test conditions. What I said was those values were measured on a 50-50 blend of salt with liquid. And of course, that's enormously more liquid than we typically use in the field when we're pre-wetting salt. But the purpose of that test was, again, to understand the limits of what's possible with my chemical system. So I wanted to start by seeing what's the biggest bump that I'm ever likely going to get in ice melting speed. So I used a very, very high liquid application level. Next, what we did was we started addressing the question of, okay, now that we've seen that under the best conditions we're getting maybe a 7-fold increase in ice melting speed when I have a large amount of liquid, mag chloride liquid pre-wetting my salt, what happens if I drop my liquid level down? So what we did next was we looked at pre-wetting application rates that were lower. We looked between 32 and 370 gallons per lane mile of mag chloride liquid. The interesting thing we saw was that there was no significant difference in the improvement of ice melting at the 4 highest liquid application rates. We didn't start seeing a drop in the ice melting speed until we got to that very lowest application rate of 32 gallons per lane mile. And interestingly, that was the application that was low enough that for the first time it did not completely cover the ice. So what does this tell us? It tells us that when we're pre-wetting, it's not as simple as saying the more liquid, the better. And frankly, that was not what I expected when I went into these tests. What I was expecting to see was that the more liquid I added, the more quickly the salt would dissolve, and therefore the faster the ice would melt. That's not what I saw. Under these conditions, there is a limit above which adding more liquid does not give you any further benefit. So there's some optimum ratio of deicer liquid volume to deicer surface area to pavement surface area that maximizes the increase in ice melting effectiveness. And we need to determine what that is through further experiments. But what we can conclude is that with pre-wetting, it's not the case that simply the more the better. In addition to those tests that I just told you about, we also looked at some application rates of liquid that are more like what we actually use typically nowadays in pre-wetting. And that's what you see here. This graph shows you the percent increase in ice melt compared to dry salt for salt treated with between 8 and about 64 gallons per ton. What we saw in this test was we were having difficulty seeing much difference between 8 and 15 gallons per ton. I don't think that necessarily means that there would be no value to going from 8 to 15 gallons per ton. I think we may be limited again by the limits of precision in the test method. Even with the improvements, the current test method still is more variable than I'd like, and so it does limit us to a certain extent in measuring differences. But what we're seeing is that at kind of current application rates of around 8 gallons per ton, we're seeing something like a 30 to 40% increase in the ice melting speed at -4 Fahrenheit compared to dry salt. And there's further benefit to be gained at higher liquid application rates. If I go to, say, 32 or 64 gallons per ton, I can get substantially more ice melting speed than I can at my lower application rates. So there's probably benefit to be gained by using even higher liquid application rates than we're currently using. And I think further work will be merited to better understand what those optimum levels are.